Hello, everybody. Welcome to our senior project titled Investigator.net. It's a new tool to investigate the best. Our group is composed of Eli Aboud, Cameron McKenzie, Sean Patel, Hunter Stecco, and myself, Sean Toomey. Investigator.net is a new tool which allows users to track the investments of thousands of hedge funds, mutual funds, insurance companies, and other asset managers. It will allow retail investors to gain free access to professional portfolios, which will allow them to replicate the strategies of the world's top investors. We will now get into a brief presentation roadmap. So our presentation will begin with the project background, where we'll discuss our inspiration, the driving forces behind our project, why we thought that this project was important. Then we'll get into a technical approach, where we'll talk about the database design, how data collection occurred, and how our website was configured. Then we will get into a demonstration, where we will showcase our primary pages on our website and some of the actions users can take on them. Then we'll get into some implementation details. We'll talk specifically about how requests for data are sent and how they are processed, and also how our website interfaces with the database and some of the underlying engines that are occurring on our pages when users take action. Then we'll get into some issues where we'll talk about impediments and roadblocks and how we overcame them. And lastly, we'll wrap it up with the conclusion. We'll talk about how our project closed out and any other necessary details.
So first, I'm going to give you a little bit of background about our project and why we decided to do this in the first place. One of the most important reasons why we worked on our project is because of this trend of the democratization of financial services. So for a very long time, what we've seen is that financial information and access to the market has been something that has been reserved for the richest and even the most institutional investors. However, over the course of the past few years, what we've seen is a democratization in lending, financial services, and investing. In lending, we've seen people get access to sources of funding and capital that wouldn't have been available to them just 15 years ago. In financial advising, we've seen new information about how to build portfolios available in the form of companies like Wealthfront and Acorns. And then in investing, we've seen individuals have access to market products that would have been reserved for, again, those institutional investors, made available through services like Robinhood. The results have been impressive. Not only have people been able to access the financial system and the markets in ways that they've never been able to do before, but they're also able to do so at a cost that is low and affordable for the average consumer. So finance, however, has suffered from the ability to democratize the information that makes the market work the way that it does. These large institutional investors still have the benefit of knowledge. So credit card transaction data, satellite imagery, consumer browsing histories, social media sentiments, expert networks, all of these things are pieces of information that the general public does not have available, even if the general public is able to access the market in ways like the major institutional investors can. This informational edge obviously gives the institutional investors an edge also in their ability to turn a profit in the market. Investigator.net, our project, comes in at that point. Basically, our idea is that we are going to give that information, which is publicly available through the SEC, to the people who need it. Access to millions of ownership records for registered investment advisors, again, through the SEC, dating back to 2015, is all going to be available at the fingertips of a small-time investor. Also, we're going to be able to give them analysis tools so that they can take a look at all of this information in a way that allows them to make sense of what they're seeing. An Investigator is a service that's free for everyone, giving the Wall Street resources to people in the greatest need of those services.
We'll now move into the technical approach we took to building the Investigator, starting with the raw data gathering process. The data for this project comes directly from the SEC's Electronic Data Gathering, Analysis, and Retrieval System, also known as EDGAR, which is able to compile all types of regular SEC filings and public financial statements. Though individuals are able to perform simple queries directly through the SEC website, scripting was required to scrape and download the enormous amount of holding and filing information that went into the Investigator. This process is controlled through an R script, running on a compute node within the Case Western high-performance computing cluster. A local client initiates the script by submitting a job with a specific year and quarter of interest. The script then extracts a master index of filings for that quarter and filters out to filings that are relevant for institutional investors. It then is able to construct appropriate file paths and parse through the Edgar filing system to extract metadata for these investors, and finally, all their holdings for the quarter in an XML format. These results are then passed through an XML parser and converted into two tabular data frames connected by the investor's central index key. One table contains the full list of investors and their relevant metadata, while the other maintains the full set of their holdings for that quarter. This data is then returned to the local client through a secure copy procedure, where it can then be passed on to our database.
So after we scraped the data, we decided to go with a MariaDB database as our solution to store the data. And MariaDB is just a forked version of MySQL that's more compatible and flexible with Amazon Linux, which is what we're using for our server. So pictured here on the slide is our entity relationship model. And as you can see, we use 4 table structures to organize our data. So starting on the top right is the filings table. And this is simply a listing of every hedge fund that completed a 13F filing for that quarter. Just for insight, we are holding data from Q1 2015 to Q1 2021. And so there will be one table for filings rep for each of these quarters. And this is associated with the holdings data, which is a listing of every transaction per quarter. So similar to filings, there's a holdings data table associated with filings for every quarter from Q1 2015 to Q1 2021. And these are going to be connected via a CIK number, which is a central index key, uniquely identifying every corporation or issuer or stock during that quarter. So now moving on to the bottom of the entity relationship model, we have our company data and industry data. The company data table is simply holding the outstanding shares broken down by year and quarter for every company whose stock was bought by a hedge fund during our time period that we're analyzing, whereas the industry data is a breakdown of all the industries that these companies work in based on what's called an SIC, or standard industry classification. And this is broken down into 3 different levels, and we will be using this to assist with the visualizations on our front end.
Now, our network configuration is very similar to what you'd see out there in the wild. In fact, there are tens of thousands of professionally built websites that use pretty much the same setup. Basically, there are 4 parts. We have an authoritative DNS server hosted by Google, and then we have an Apache web server, a Tomcat web server, and a Maria database, the 3 of which are all hosted by AWS. Here's how it works. Suppose we have a client. Let's call him Bob. Bob types in our URL, investigator.net, into his browser and clicks enter. His browser then communicates with our authoritative DNS server in order to figure out our IP address. It takes that IP address and then submits an encrypted web request to our Apache web server. Our Apache web server then decrypts that request and passes it along to our Tomcat server. Our Tomcat server parses that request, figures out what data it needs in order to fulfill that request, and submits the relevant SQL queries to our database. Our database responds with the raw data, and then Tomcat packages up that data into a web page using HTML, CSS, and JavaScript. Then it sends that web page back to our Apache server, which encrypts it and caches it, and finally passes it back to Bob.
Now we're going to do a very brief demonstration of our Investigator website so that when we talk a little bit about some of the back-end coding, you'll have an idea as to how it's actually implemented in the use of the website. Here you can see our homepage, which combines the themes of Wall Street and this detective theme that we established with the Investigator branding. You can see up in the top left our overall logo, which was something we designed ourselves, and combines those 2 themes together. Clicking on that logo brings you back to the homepage from wherever you happen to be at any time. The investments, institutional investors, and consensus picks pages provide the 3 different main features of our website. The investments and institutional investors page provide 13F data from the perspective of companies and institutional investors, or things like hedge funds, respectively. The consensus picks page provides information from the perspective of overall leaderboards, but we'll talk about all of that later. Now I'm going to pass it off to Sean, who's going to show you the rest of the homepage.
So scrolling down here a bit, users will be greeted with a brief description of the 3 primary pages and what they can expect and leverage from them. And that is essentially what I just finished describing. So users can just get a quick glance at what they can expect in each of the pages. Scrolling down here a bit, we have our institutional owners pop out on the right and a brief description here of why investigator.net is a good tool and how it can be put in the hands of users for good. So it discusses how institutions nowadays are able to shell out millions of dollars and gain an unfair advantage over typical average everyday investors through various means of pulling data from credit card transactions, satellites, browsing history, and other unfair advantages that a everyday investor cannot possibly be able to utilize. So investigator.net, fortunately, is a tool which will offer the everyday investor free access to professional portfolios and extensive data, which will help them replicate the strategies of these top investors and be able to succeed in the stock market, all for a non-existent cost. So scrolling down here in this next section, we have a rotating profiles of our team members. So we have our profile pictures, our names. Each slide will share our degrees, our anticipated graduation year, as well as links to our GitHub and LinkedIn accounts, which a user can click to check us out on those various platforms. And scrolling down a little bit more now, we will see kind of some essential benefits of investigator.net that a user should be aware of that they're going to get out of using our tool. These being comprehensive records. Our database is extensive and has a lot of good information in regards to companies and hedge funds and those trends that a user might want to be aware of. The tool is free forever, so not only will users not have to stress about a insurmountable subscription fee, but they won't have to worry about what they are paying increasing over time unfairly without much control on their end, because our tool will be free forever. And lastly, historical coverage. Our tool will date back 5 years and it will be updated frequently every single quarter, so users can always expect fresh and reliable information from our website. So just going down here in our footer, we have a couple important links that users may want to check out. We have our privacy policy, which describes how we retain our cookies and user preferences and how users' data will be protected. We also have our licenses, where users can view our photo attribution and other licenses for templates and any other things we leveraged in this project. Then users can also check out our source code, so they can head over to GitHub and view all of our source files and our commit history. And additionally, there's a contact icon where, beyond signing into the Case email account, a user will be able to send an email right off to investigator at case.edu, or if you're not a Case user, just sign into your usual email platform, and then you'll be able to send us an email directly. And then over here, we have 2 social media icons. So the first one being our Twitter account, which will take you to Investigator Twitter, and then our Investigator Facebook profile will also be linked here, so users can choose to follow us on social media and follow our presence or interact with us or reach out to us through there if they so choose. So that's it for the homepage, and we will now get into our 3 primary pages.
We continue our tour of investigator.net by taking a look at 2 tabs which essentially function in very much the same way, but present similar information from a different perspective. The Investments tab presents information about which institutional investors hold stock in a particular company. The Institutional Investors tab presents the information from the hedge fund's perspective, or from the fund manager's perspective, showing all of the companies that a particular fund owns. So both of these tabs work essentially the same, just from these different perspectives. So we'll demo the Investments tab in depth, and then we'll just show all of those features, which essentially would just be from the different perspective in institutional investors. Let's go ahead and take a look at a company that we're all familiar with. Let's say Nintendo. So once I type in Nintendo, and you can see here that there was a predictive search algorithm that basically queries the database that's behind all of this live as I'm typing in my information. Once I go ahead and input that information to the search bar, I can hit the search button. And I'm presented with first this massive summary table. The summary table can be sorted by which quarter I'm interested in, and I can also export all of the data to a CSV file, which shows all of that information in an Excel format. Here I can see the fund name, so the name of the manager that owns stock in this particular company, the shares that are owned in that particular company by that manager, the value of those shares in thousands based off of the value at the particular point which the data was generated, which is on a quarterly basis, the percent of shares outstanding, which essentially means the percentage of the total shares that are out there on the market, which are owned by that particular fund, the percentage of the portfolio, which in this particular case is the percentage of the hedge fund's portfolio that is in this particular company's stock, the quarter over quarter change in position size, and the year over year change in position size. Each one of these fields is sortable so that you can see the data in a way that's going to be most useful to you as an investor. You can see all of the different company shareholdings based off of the hedge fund, all of the different values, and utilize this information to hopefully help you to make decisions based off of which stocks you want to be invested in. I'm going to turn it over to Cameron, who's going to show you 3 other graphs that are included on both the investments and institutional investors page.
Scrolling down on the investments page shows off 3 more graphic displays of the data for this security. First, the insider summary statistics table provides summary information on the behavior of institutional investors in relation to this investment over the quarter of interest. This includes statistics like number of unique buyers and sellers over the past year with respective counts of their positions. Additionally, the table displays quarterly and annual changes in the percentage of institutional ownership, as well as the net value of purchases and buys by investors for this investment. Finally, the top 3 controlling owners, defined as investors with positions holding more than 5% of total shares outstanding, are displayed alongside the top 3 investors by total value of their holding. For Nintendo, we can see that no institutional investor holds a large enough position to be considered a controlling owner. The colored bar chart below shows the distribution of institutional investor and retail or other investor ownership for this investment. The bar chart relies on our historical database to see the general movement of institutional investors and ownership of this security over the years. Here we can see that investments in Nintendo have largely been dominated by retail or non-institutional investors over the past several years, with little movement on the institutional side. Final graphic on the investments page is a tree map of institutional investors which hold positions for this investment. The size of each investor's rectangle corresponds to their total market trade volume, while the color is determined by the overall change in position since last quarter. Green indicates that the investor has increased their position, while red indicates that the position has been reduced. Lighter shades and gray tones show relative consistency in the investor's position. We can now quickly switch over to the institutional investors page, which, as Hunter mentioned, shows similar information from an inverse point of view. So we can go ahead and use David Einhorn's Greenlight Capital as an example. Hit the search button. As we can say, the overall structure of the page is very similar to the investments page, but now it represents holdings for this investor and their portfolio for the specific year and quarter. In this first table, we see these individual holdings with their corresponding values, portfolio, and time-based change information as before. Then moving again to the insider summary statistics table, we now see this manager's total assets under management, best and worst performers, and other portfolio highlights. The ownership bar chart now shows the breakdown of the investor's portfolio by sector, determined by the standard industrial codes of their individual holdings. For Greenlight Capital, we can see they've had significant decreases in total asset under management over the years, but generally focused on manufacturing and financials. Finally, the tree map shows the investor's portfolio broken out more specifically by the sectors they invest in, with sizes again corresponding to total trade volume and color determined by their positive or negative change in positions. Left-clicking on any of these boxes, say manufacturing, for example, breaks the category out into further subsections, so we can see manufacturing was composed of chemicals, fabricated metal products, and electronics. And then left-clicking on one of these again shows the individual holdings that make up that subcategory. Then right-clicking allows us to traverse back up the tree and explore that manager's portfolio. I'll now pass it over to Sean to show off the last page of investigator.net, the consensus picks page.
So here's the consensus page for our website. Just to kind of take you through it briefly, here we have a drop-down where you can filter this table. This table is populated using the same data in all 6 cases, but it's only showing the top 100 results, of course, to keep this a little more concise and relevant to what a user might be interested in looking at. So let's say I'll just guide you through each one. We're going to start with top institutional holdings, which would be just the top 100 investors or investments ranked by the percent of outstanding shares held by the institutional investors, just to see what's most popular amongst these institutions. And you can filter by the quarter here. So if I want to look at 2020 Q4, you can see it already filtered. And there you have the corresponding information for the rank investments, the ticker corresponding with that investment, the total institutional stake in thousands of dollars, the percent of outstanding shares held by institutions, and then the quarter over quarter and year over year position size changes. And we can continue looking through all these different options, and they will sort based on a few of these column headers. So if I did top retail holdings, we're looking at the same quarter, 2020 Q4, except now it's the reverse. It is sorting by the lowest percent of shares outstanding, basically looking at the most popular amongst retail investors, which is the opposite of the most popular amongst institutional investors. And we can look at another option here. So if we look at, if we're interested in, let's say, looking at what's been the hottest stocks in this quarter, we can look at most popular this quarter, or least popular if we want to see where are the coldest stocks this quarter amongst these institutions on Wall Street. And this will sort by the Q over Q change in position size. And the same thing applies for most popular and least popular this year, where it'll sort by the year over year change in position size, and we can see the top 100 or bottom 100 investments in terms of this change in year. And of course, we can continue filtering by as many quarters as we want, all the way as far back as 2015. And finally, if we finally settle on a certain bit of information that catches our eye and we want to save this in our computer, we can always export it by using the export to CSV function.
Now let's look at the details behind our implementation. From the 10,000-foot level, basically what happens is that when a client requests a particular page, that request is translated into a RESTful API call. This call is received by our Java servlet, which leverages the JDBC library in order to connect with our database and call a stored procedure. This stored procedure then executes a bunch of SQL queries simultaneously and returns all of the resulting raw data to our servlet. The servlet packages up this data into a JSON file and passes it back to our API as a HTTP response. And then within the client's browser, we use jQuery in order to splice in that updated data and show the client the page that they requested. Now, as a tangible example, let's say the client wants the data on NVIDIA for the first quarter of 2021. Well, they would navigate to our investments page, type NVIDIA into the search bar and click go. Then at that point, the browser, behind the scenes, will navigate to our API endpoint and pass in all of the critical information as URL parameters, what page they want, the QSIP of the company that they're interested in, and the year and quarter. This API call is then received by our servlet, which passes it to the appropriate handler. In this case, this line right here. This handler then calls a JDBC method, which is actually the one interfacing with our database and calling the appropriate stored procedure.
Once the servlet calls for a query from the database and receives our call, our database is designed to be able to execute roughly 12 queries at once. And we chose to aggregate our queries into multiple stored procedures in order to minimize the latency. since our backend is in Java, which is a synchronous language, at least out of the box. And so we found that when we submitted queries individually to the JDBC package, it resulted in much higher latency. So rather than having those queries called individually for each item that will be displayed on the main page, by using stored procedures, the entire page can be loaded in just one round trip. And so with these stored procedures, there are 5 major API calls. And so we have one procedure for each one. 3 of these correspond to the 3 main pages for investments, investors, and the consensus page. And the other 2 correspond with the search bars on the investments and investors pages. And for each of these, there's a sequence of multiple queries populating the data on each of those tables for investments and institutional investors. Our queries will be able to aggregate all the data for our large summary tables, then the individual summary statistics that are being computed, along with the data to populate our stacked bar chart and heat map. And then with the consensus page, it'll return 6 queries, each pulling from the same table, and that can be sorted by year or quarter, pulling the same data organized in a different way. And then with all those 3 procedures, we're using temp tables in order to further minimize latency. So we're not just pulling from all of our other tables and not having to do multiple joins repeatedly. We want to minimize the repetition of queries as much as we could. And then with regards to the search bars, I will talk about that in a later slide. But before I go into that, I just want to touch on our SQL queries we're using outside of those procedures. I'd like to classify these into 2 different categories. The first are the multiple computations we're doing, either quarter over quarter or year over year for each holding, wherever it's feasible to calculate. And what I mean by that is, for example, our data goes back as far as 2015 Q1. Of course, it's not feasible or possible to calculate a quarter over quarter change for that quarter because there's no previous data that exists. And in the same sense, for 2015 Q4 data, we can get quarter over quarter data, but we can't get year over year data because, of course, we do not have access to the corresponding quarter in the previous year, which would be 2014 Q4. So with that said, the 4 major computations we did for each quarter's data are listed here. The first being the share count. We wanted to see the change in shares among that institutional investors were holding. The next would be the holdings ratio, just to see how much the allocation of, or how much the outstanding shares changed with regards to how much the institutional investor was holding from those outstanding shares. The third would be seeing the change in the value of the holding over the quarter or over the year. And the final is the stock price changing over that quarter or year. And those first 2 at least are expressed as percents. And while those last 2 are expressed as, or all 4 of these are expressed as percents. But yeah. And then finally, the other classification we had would be the row calculations. These were done, I put these in a separate category because they are not necessarily a comparison looking for between quarters and years like the previous ones, but rather are calculations just within the row just to get a better idea of what's going on with that investor and in that holding for that specific quarter or at that time frame. So the 2 major calculations we had were the holdings ratio and percent of portfolio. The holdings ratios here were calculated prior to the quarter over quarter, year over year, because these were the values that were compared through multiple time frames. But these were calculated by comparing what the outstanding shares were to the value actually held by the investor. And then with percent of portfolio, we wanted to see how much a single holding made up, or the allocation of a single holding to the investor's full portfolio, because this is obviously very crucial information to see to determine more of the weightage of a certain investor's portfolio and how much of a certain industry are they holding. And so finally, like I alluded to 2 slides ago now, with those procedural queries, while the first 3 procedures were populating the actual data on the pages, the last 2 we had are for populating the search bar results. So we used a special indexing exclusive to SQL known as full text search indexing. And we use this to provide live results in the search bar on both the company and institutional investors pages as the user actually provides that input. So the process at a high level is that the user can type a character or multiple characters into the search bar on that corresponding page, and the corresponding procedure, whether you're on the institutional investors page or the company/investment page, there's one stored procedure for either search bar. That procedure is activated. And then we designed special tables to be used in these stored procedures in order to speed up this search process. But basically at a high level, we've implemented this index on either all of the investment/company names or all of the institutional investor names. And so what the stored procedure does is, as the user types, this procedure will be activated in the database, and it will return to the search bar matching results that start with that character or the previously typed composition of characters. So as an example here, let's say I was looking up APPL, maybe I'm looking up Apple or any other company that starts with APPL. And here are the results being populated below. As I would type, these results will get increasingly more specific. And so this is much better than the other method you could do this in SQL, which is using the like keyword, because full text search has better algorithms running on the background that makes this much faster and more efficient, which we think is a very unique plus point to Investigator.
Picking up with our earlier NVIDIA example, once the database is done doing its thing and spits out all of the appropriate data, this data is received by our server, again using JDBC. After it's received, it's parsed into a JSON format and served back to the client at this URL right here. Now, even though the page associated with this URL wouldn't actually be visible to the user, we included a screenshot of it below to give you a better idea of how our site is actually working. So on the left, you can see different JSON keys, each of which correspond to a feature that we've implemented. On the right, you can see the data associated with those keys. Now, once this JSON file is loaded, we use both vanilla JavaScript and jQuery in order to splice it into the DOM and make it available for the user. Another technology we used was cookies. Specifically, we implemented them using JavaScript and leveraged them in order to allow the user to save their preferences on different investors. So in the example below, you can see that the user loaded data on Greenlight Capital, Berkshire Hathaway, and Pershing Square Capital Management, 3 very famous hedge funds. Now, suppose that they close their window and maybe go out and do other things on the internet. When they eventually return to our site in a day or a week or a month, they'll see that their preference for these 3 hedge funds was saved in their browser. Now, we managed to implement this functionality without keeping any user data at all at the server. However, just to alleviate concerns regarding privacy, we explained our cookie policy and our privacy policy in the footer of our site. And then finally, the aesthetics. So our user interface was implemented using JavaScript, jQuery, CSS, and HTML. And we used a hodgepodge of different types of graphics in this project as well. Our icons were from fontawesome.com. Our photos were from Shutterstock. Our graphic fonts that we used on the homepage were from Google Fonts. And then the charts that we used incorporated the Google Charts API. And then some of these icons and photographs were photo edited, and we used Adobe Photoshop in order to accomplish this. Now, it's worth mentioning that all of the different libraries, pictures, and other graphics that we used throughout this process were properly licensed and were appropriate. The credits were included in a link at the footer of our page.
We will now wrap up our presentation. To conclude, investigator.net is an indispensable tool to put in the hands of retail investors, as it allows them to succeed in a stock market which is very expensive to stay on top of. It provides everyday people with the benefits of millions of dollars worth of Wall Street research at a non-existent cost to them. If you'd like, you can check out the site yourself at www.investorgator.net. If you'd like to view our licenses, photo attribution, contact information, or any of our social medias, you can feel free to do so at the footer of our site. Thank you for listening to the presentation and have a great day.